3 inverse is not 4 mod 7.
A 5.
The multiplicative inverse of 3.
It is
Yeah,
5.
5 works. Okay. Yeah, 5 works. So you also have something similar. So this happens mod 7 or Z mod 7 Z, whichever you prefer. But you also have something similar going on in Q, right? Which is that the numerator of this is
So you are involving the
well in the
like
lowest term.
subtracting with
This
fractions
is
here.
like,
Okay, nice.
yeah. So this thing works in Q, whereas this equation is in Z mod 7Z. And you can have something so similar. So let's say I define P divides A by B. You can only, well, supposing this is in lowest terms, I define P divides A by B if P divides, well, P does not divide B, and P divides A, right? And with this definition, so this is sort of uh, extending division to Q. Uh, usually just work in Z anyway. So so let's try out one more example. What's let's say in Q, what's half plus one third? This is 5 by 6, right? And let's take some prime, let's say 5. What's 2 inverse plus 3? Mod 5.
0.
Yeah, I'll just write that as 5 times 6 inverse. Or let's say if you take 7z, again 2 inverse plus 3 inverse is what? This is 2 inverse not 7, 2 inverse not 7 is 4, and this is 5. This would be 9. Is this 5 times 6 inverse? Can someone verify that? What's 6
Yeah.
inverse?
6. Yeah.
Yeah, 6 inverse is 6. So this thing is 5 times 6, which is 30, which is 9 more. So see, and this happens, well, almost all the time. You cannot do this mod 2 or mod 3 because these don't make sense mod 2 or mod 3. But so for almost all primes, you have some special problem which really. So let's say, and I want to show P divides try it.
Oh, can I tell the solution?
Sorry.
Can I tell the solution?
Still could not hear you. Repeat again.
Okay, sorry. Nothing.
So has anyone seen this problem before? Or maybe you have seen a stronger version of this problem.
I think like the proof of Euler's theorem is somewhat similar to this.
Okay. Ideas?
Just inverse is bijective, right? So then, like,
Yeah. So you are using,
Except number one. Except the one.
inverse is directive except the one.
Actually, like we are seeing that till half to b minus 1 we have inverses of each other, but for 1 we don't have an inverse. So for 1 the inverse is b, so we can easily show that it divides the numerator.
That way. Sure, that makes sense. Okay. So you do 1 by I plus, right? You get a P everywhere and things work out nicely enough, right? And this works. But if we try to do it the same way we did, wait, what if we try to use the correspondence between, then this would be congruent to what? Then what we want to show is what theorem does this using. I'm not using any theorems. I'm not using any. And so what? Yeah. So two ideas is to pair these up, and each of those will be of the form. It will be p times. That was the first idea. The other idea is to yeah, that's the name. Wolzenstrom something something. So the other idea is to use the correspondence we talked about, and then we want to talk about one inverse plus two inverse plus up to e minus one inverse mod. And uh, we want to show that this thing is zero mod. Right? Can everyone, anyone wants to explain why? Like we have, like, anyone wants to
Uh,
explain where this is
isn't the in isn't the inverse the bijective function to the set itself?
Yeah.
Like
So the inverse is a bijective.
inverse 1, inverse 2, they are like bijective.
Yeah. So this sum is exactly 1 plus 2 plus dot dot p minus 1 in some order,
Yes, yes,
which
yes.
is p times p minus 1 by
You do
2.
act.
And you see where this condition comes in, right?
Yes, yes.
This
It
is not
smartly
divisible
uses the
by p
condition
unless
here.
great. So, okay, that works. What if we want to do this? Maybe you need bigger than 3 or something, but yeah. Here's an example. Let's see. Uh, I'll leave this as an exercise. All right. Let's move on. Also, maybe whether PQ works for anything. Okay. So, uh, anything anyone wants me to repeat so far, especially this correspondence.
For the
Great.
p square question, is the proof using just pairing, or is it with the correspondence?
You can do it using pairing
Okay.
or the correspondence, both work.
Okay, guys. Yeah. Okay.
Yeah. Okay. What should be the next module? So, for a second, let's just play around. Let's forget that there's a thing called rigor. Let's just play around with numbers and see what happens. So let's say half mod 5. So I'll try to do Euclid's lemma. I'll try to do Euclid division on half with 5. So half is, let's see, 5 times minus half plus 3. And then I get minus half is 5 times minus half plus 2. And then again, goes on. So I put all of this together. I do 5 times 5 times minus half plus 2 plus 3. This is 5 square times minus half plus 5 times 2, right? And you know, again I'll open this minus half, put this in place of the minus half, and get a 5 cube thing. So eventually what happens is I get 5 to the power 0 times 3 plus 5 to the power 1 times 2 square times 2. And when you look at this, your first reaction should be that this is a very finite thing. This does not look like a finite thing. I mean, this does not look like a sequence which has a finite sum. Right?
And plus it is
This looks like
integer.
yeah, with the fact that it's an integer, the positive integer. Yeah, but let's still just play around with the ideas and see what happens. So if I write this in base 5, so does everyone know how bases work? Base 10, base 2. Should I give a brief review of how bases work? All right.
A bit
So
of you can give a bit of a review.
sure.
I just don't remember.
So yeah. Let me see. So we usually work in base 10. That is to say, whenever you write down a number which is even something like root 2, you write down as 1 times 10 to the 0 plus 4 times 10 to the minus 1 plus 1, this is 1.4142 something like that. 4 times 10 to the minus 2. But the thing is, there is nothing special about 10, right? Well, the only thing special about 10 is that we have 10 fingers. Well, most people have 10 fingers. The average person has more than 10. The average person has less than 10 fingers, but yeah, that's the only thing special about 10, right? We can easily write down things in other bases. 7 in base 10, I can write it down as 1 times 2 square plus 1 times 2 power 1 plus 1 times 2 power 0. So this is 111 in page 2. Does this make sense?
Yeah.
Yes, you have written binary.
Yeah, great. So, and you can also you can have 2 power minus 2 and all that. So so base 10, the digits are 0 to 9. In general base n, the digits should be 0 to n minus 1. Great. With that being done, let's write half in base 5. This would be 3, 2, 2, 2, 2. Well, this is not the actual extension of half in base 5, but you get what I'm trying to. Do you see where these numbers come from? No? 2, 2, 2, 3. These
Yes.
are just, yeah. And if you try to add these, and we are working mod 5. 3 plus 3 is 6. So 6 is 1 mod 5 and 1 gets carried over. Then 1 plus 2 plus 2 is 0. Again, 1 plus 2 plus 2 is 0, 0. So somehow, we get that half plus half is 1. Well, things work out nicely enough even though we are working with infinite things. Okay. What else can we do? So half was dot 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 2, 2, 2, 3 mod 5. What's half? What is the inverse of half mod 5? Well, not say half. What's 2 inverse mod 5?
3.
3.
Okay, I should probably go faster. What's 2 inverse mod 25?
13.
13, and which is 23 in base 5. What's 2 inverse mod 125?
63.
Great, which is 2, 2, 3 in base 5. So you already see that good things happen.
Yes, it makes sense. According to
Yes,
that,
and can
infinite formula
you
makes
prove that
sense.
this happens?
Can we try an inductive approach for this, like for 5 to the n?
Sure.
So we have for 3 and for n is equal to 1, it is already proven. Now we assume that n is equal to k is true. Now then we need to have that n is equal to k plus 1. also is true.
Okay.
We simply notice that 2 inverse.
So the thing is, 2 inverse mod 5 power k. You want to know 2 inverse mod 5 power k plus 1. That will
Yes,
be your
yes.
induction. Yeah. And you have to show that this the way you go from here to here, same thing happens. So like the numbers you get are the same numbers when like at the kth step of this process. That's what you'll have to show for the proof to work out, right? I'll just
Wait, can you explain how 1 by 2 is 2, 2, 2, 2, 3 mod 5 again?
yeah, sure. So 1 by 2 is uh, I'm trying to do Euclid division. 1 by 2 is 5 times minus half plus 3 because this I need to be between 0 and 5, 6, 0 and 4, right? And this is the only way to do it. So half is 5 times minus half plus 3. Again, I try to do the same thing with minus half. It's 5 times minus half plus 2 and so on. So half is 5 times 5 times minus half plus 2 plus 3 and you get this. Then you keep opening the minus half. You keep getting this expansion.
Oh, yeah, okay.
All right. Uh, okay. What should we do? Let's try to.
Should we try another basis like we have tried in 5? Does
Yeah, you
this
can
infinite
do that.
sum exist?
Yeah, it works. It actually works. You don't even need it to be a prime. The prime, like prime condition, is they required for. Like, you will see later why you require the prime condition. Does that things work out better when these are primes? You have multiplicative inverses of almost all the numbers. But even if it's not a prime, this infinite sequence thing still works out.
Yes.
Great. Okay. So so we know how to solve in R. The solution is root 2. Let's say we try to solve it. Let's say we try to find root 2 mod 7, actually plus minus root 2. Root 2 mod 7, root 2 mod 49, but 7 cube, 343, and whatever. So this does not make sense because root 2 is not even a rational number. I defined division for rational numbers, but root is not even rational. So you will have to
Yes,
work
we are losing
somewhat
a bit
makes
of figure
this.
here.
So what we can do is by doing can you solve for this? I want to x such that x square minus 2 is 0 mod 7.
It is congruent to x squared minus 2 is 0.
Okay, what is the value of x?
3 is such a value.
3 and 4. You get two things
Yes.
because there's also a plus minus here. What about
9, I guess.
uh, 9 does not work, right?
Yes, it is not work.
10 and 39.
Yeah. The 10 works. 39, not sure, but probably works. So
Just
one thing is that 10 is the extension of 3, and this is the extension of 4, right? Because 10 mod 7 is 3, and 10 mod 7 is 4. And right, so what is 10? 10 is what is 10 in base 7? If I'm correct. Yeah. What about you don't actually have to compute it, but I want the extension of this. This will be something then
1,
1
1,
3.
3. Yes, yes. Like the ones that will be repeating again and again.
Would they actually repeat?
Like that 2 repeated in the half thing, it one should also repeat here.
But half is a rational number, right? So e- even if you are working like not in mod 7 but in R, the decimal extension of root 2 is very different from decimal expansions of half or any rational number.
Yes.
One, I do not think it works. One would be what? 49 plus 7 plus 3.
It is still 3.
So does this actually work?
Yes.
Oh no, does not work, right?
Then
113 is not a
yes.
solution. So, but the idea is that you get a expansion of root 2 mod 7. Well, plus or minus that, but right? Does this sentence make sense? Does this line make sense? So same thing as we did here. Right? Where's the half case? So for half, like I did the expansion earlier, and then I talked about inverses. Inverses mod 5 power n. Here I'm doing the opposite. I did the mod 7 power n thing first, and then I want to talk about the expansion. Is this fine?
Yes.
Did, anything anyone wants to repeat? You want me to go faster, slower?
But what is the sorry to say, but is there some like insight
So
of using this?
is there some sort of? I really can't hear you for some reason.
Like, is there some sort of motivation of using?
Yeah. So I mean, it looks like a fun thing to do. I mean, playing around with
Yes,
numbers,
it is
but
like
other than
yes,
that, yeah.
yes.
So I'll tell you. So the motivation is well, you'll see the motivation. Like it's to motivate it. It's a bit hard because I'll have to use formal terms, and I don't know how to motivate it nicely enough. But the thing is, you get some other form of algebra or structure than you are used to. Right? You are not you're not used to this kind of you know structure,
Yes,
and
yes. We are not.
so when you have a new kind of structure and like this structure looks like it behaves good enough, whatever good enough means. So usually when that happens, it's a good thing. It's a good thing, mathematical thing to care about. So there are two things we did, right? We solved the first thing we solved 2x minus 1 mod 5, and then we solved x square minus 2 mod, well actually 5 power n, 7 power n. This is exactly like the solution to this will be 2 inverse, right? And the solution to this is root 2. So we found 2 inverse mod 5 and we also found root 2 mod 7.
But surprisingly, integers arrive here in the irrational thing over here also.
Yeah. All right. One more thing before I formally, sort of more formally define what a p-adic number is. So I assume you have seen this kind of thing, infinite GP, and this makes sense, right? And anyways,
Yeah.
if anyone has not seen this, I can give you a very quick proof of this if you want to. So and for people who have seen this, can you make sense of this? Yeah, and if anyone has not seen, please ask me. I'll give you a quick proof of this.
Can you give the proof of the formula?
Yeah, sure. So let's say S is
Oh yeah, this thing I know that S is equal to R to the n minus 1 by R minus 1.
yeah, or you can do this. Well, the question you might have is,
Also, you are involving infinitely many, so there it does not make sense of any pairing or
But
anything like that.
isn't this formula used only if it's like if R is lesser than 1 or something?
yeah.
No,
So
like if
we can't use
the
it for like 1 plus 2 square stuff.
Yeah, but like we still somehow want to make some sense of this using. So you
so
have
you are
already seen
using
that. So
infinitely many terms to make the sense of this formula.
yeah, so you have seen that we have an infinite term expansion of root 2, right? Like this thing, if you look at it as an actual number, mod 7, it's a big number. It's whatever, like biggest possible. Like, it's infinity. If you look at it as a normal number, right? We get a 3, 1, then something. Same thing for 2 inverse, right? So like maybe this also makes some sense. That's what I was that's what I was trying to go towards. So this is a good exercise. I gave you a proof of why the sum is 1 by 1 minus r. Can you tell me where we are using the fact that mod are less than 1 in the proof? Side exercise. If you know some calculus slash analysis slash
because it
sequential series, blah blah blah.
because then it won't be a convergent series if model.
Yeah, exactly. So you can't actually like manipulate series like this before you know they're
Yes,
convergent. But
yes, pairing
it
doesn't
is,
make sense here.
sorry, what does not make sense?
Like in the general formula for a finite n, the pairing makes sense, but here the pairing does not make sense, so we just assume it that all the things cancel out.
Yeah. So let's try to solve this. We'll try to make some sense of this. All right. What's minus 1 mod 2? 1, right?
It's not one, yes,
What's minus 1 mod 4?
3.
3.
Which is 1, 1. So if we just follow whatever we were doing, we get that minus 1 is, and if I expand this out, this is exactly 1 times 2 power 0 plus 1 times 2 power 1 plus 1 times 2 square, right?
Yes.
Yeah.
Is this fine with everyone? So the
Yeah.
thing is, I have not defined everything formally. So you, like most of you will have a itch in your head that what's actually happening behind all these random looking calculations. So like the fact that so many nice things are happening means that there must be some fundamental structure behind these random computations we're doing. Wait, so I guess I have motivated you enough to tell you the general definition. Ah, let's see.
There is one thing that is slightly weird about this, and that is that the left hand side is like negative, and like everything on the right hand side is positive.
Yeah,
So
exactly.
intuitively, that doesn't make any sense. Like,
Yeah. You
No,
also
that's
you
because
had
minus
seen,
1 mod 2 is like 1, and like mod 4 is 3, it's positive.
but what you're saying is that this sum does not make sense because this thing is extremely positive and on the left hand side you have a negative. You had similar things here, right? This thing was, integers, whereas this is a
I think
irrational.
extending the modular arithmetic to a bigger number system implies these things.
And a similar thing here. This is rational. This is less than 1, 1 by 2, and this is a bunch of integers. What is it? 3, 2, 2, something, something. All right. Anything else? I'll just wait a few seconds. So I talked about 3 examples. Just make sure that all of those are clear with us. We're going to generalize this, so it helps to have specific examples in mind when you are trying to generalize. This was D1 something. Okay. P-adic integers. I will denote this by ZP, which is very, very different from. Okay. So what do elements of ZP look like? Elements of ZP. This is what our elements look like. Is this fine?
yes.
Great. So can you see that Z lies inside ZP?
Yes, it lies inside this.
Yeah, so elements of Z are exactly the ones which have a finite expansion, right? Z.
Yes, finite. Yes, finite expansion.
Yeah. So a general element of ZP might have an infinite expansion, but if the expansion is finite, you get element of Z, and vice versa. So this is an extension of Z as a ring, but yeah, it's an extension. It's a bigger number system than Z, and you can define addition, multiplication, and all that here. The usual way. What else can we do? So, well, there's another way this is expressed. This is also expressed as a0, a0 plus a1, b. So these are the expansions, the different ways of writing. Right? The ith term is just the thing mod p power n. Make sense?
Yes.
Yeah.
Great. Okay. What more can I do? Should we actually not? Should not actually try to compute root 2. What can I do? What can I do? So do you guys know like formal series generating functions?
Can you
Can you
repeat
just
what I was
repeat what
saying?
you said?
Do you guys know what a formal series is? What a generating function is?
Sorry, can you type it, please? I'm really unable to understand what it is.
So a formal power series is kind of a generalization of a polynomial. It looks like this.
Yes, yes.
So let's say I call this a of x. Do you guys know when and if you have any of you seen this before? So for example, if a of x is 1 plus x squared, can someone tell me what b of x should be?
X minus 1.
1 minus x.
1, yes, 1 minus X. Sorry.
One.
Very good. So, okay, you probably have not seen this, but okay, you can figure this out when this happens and all that. So, what we are doing is kind of essentially doing what we are doing with p-adic numbers is like formal power series, but evaluated at x equal to p in some sense. So that, and since formal power series behave nicely, you have all structures, theorems, and all that. P-adics also behave nicely. And okay, let me do the sort of more analytic point of view. So suppose I want to define a norm function on Q. And what does that mean? So I want the function to be okay. Should I do this? Have any of you seen what a norm is? Okay. So norm is just a function such that, and maybe I'll need basically trying to wait. And can anyone give me an example of a norm on Q?
Your voice is actually not very clear.
Oh, okay. Better now?
Yeah, I think yes.
Yeah. Can someone give me an example of a function on Q which satisfies all these properties?
Just the usual norm, like
Yeah, just the usual absolute value works. Right. So what I want is a function well, such that f of a is 0, sorry, f of a is greater than equal to 0, and equality happens on A equal to 0. I want f of AB to be equal to f of A and f of B, and I also want so the way you should think of f is that f of A represents the
Can't it be some power series?
can I
Like
do
some
some?
exponent? Yes.
Sorry, I do not understand what you said. Can you type it in the chat or something? So the way you should think of fa is that fa represents the distance of A from 0, and you see then this condition just says that you know everything has a positive distance from 0 other than 0. This condition says that distance is multiplicative. Distance of AB from 0 is the distance of A from 0 times the distance of B from 0, and this is just the triangle inequality. Is that all right?
Yes.
Okay, so one example of a just the absolute value of A, right? That satisfies all of these properties. It's greater than or equal to 0 unless A is 0, and it's multiplicative and it satisfies the triangle inequality. The thing we want to know is, are there other distance functions on Q, like, which are very different from this? Take a guess.
Nup of the numerator?
Nu P of the numerator, that almost works, but that's not multiplicative, right?
Oh, okay, yeah.
Can you give another example of FA?
Exponents also doesn't work here. The third condition is somehow stopping it.
Like f of A equal to root of absolute value of A also works, but this is not really different from this. There is, in some sense,
We are just involving like squares and some powers. For any power, it would satisfy.
okay. So can you see that it suffices to? Okay, let's see.
Oh, P raised to Nup of the numerator.
That also almost works. That
Okay.
still, that's very close to the answer, but does that P raised to nu P
Can we
probably
work
does not
with power series here? Some power
How will you
series
work
would
with
be
power
nice
series?
here. Yes, I want to include power series there somehow.
Sorry, how will you want to get a norm using a power series?
Yes.
Okay. So you want F to be a power series, and
Yes, some arbitrary power series that satisfies all these three conditions. The first condition makes sense; it will satisfy. On second and third,
power series will probably not work.
the
As a
third
sad part.
condition is somehow some spiky condition. It just like restricts all the.
You see, AB might be negative also, right? Not just positive. So handling power series will be hard.
Yes, but the third condition contradicts itself. The third is enough for contradicting.
Sure. So here's the other kind of. Before that, does everyone know what this expression means? This means the so V2 of 36 would be 2. V3 of 49 would be 0. Does the notation make sense? This is just the highest power of P that divides n.
Yes, got it.
What do you think we should define this to be? How do you think we should define this? What would be a good definition?
No, if n is not divisible by p, then Vp of n will be 0.
Yes.
It will be VP of A minus VP of B, I guess.
Yeah, that's a good definition. Right. So V2 of 1 by 100 would be minus 2. Great. So let's see some properties of VP. So what we have now is VP is a function from what Q to, and let's define VP of 0 to be Q to Z. Well, actually Z even in infinity. Right? VP takes elements of Q and outputs elements of Z.
Wait, why
Or it-
infinity?
What's the highest power of P that divides 0?
It could be anything.
P power anything
It
divides
can
0,
be
right?
very
So
large, infinite. It does make sense, right?
Isn't it supposed to be like 0 or something?
but 0 would mean that, I'm sure 0 also probably works in some cases, but 0. So
Then how can we agree upon infinity? Like not defined is a better.
We are looking for the highest power possible, so we should look on infinity because it does make sense.
you can treat infinity as an object, just a formal object, or let's just not do VP on 0. Let's just do this on non-zero rationals. So VP of R1, R2 is VP of R1 plus VP of R2, right? Can someone give me a proof of this?
Or we can give by logs and things. We can involve log here.
No, this is just the highest power of P in R1, R2, right? That's just highest power of P in R1 plus highest power of P in R2.
But we can take the floor of log, na? We
Is
will take the floor.
is p prime?
Yeah, P is a prime. You don't need P to be prime so far, but
Hey,
floor of
you
log
do.
would,
If it's like, for example, if it's 4 and like R1 has like a multi, R1 is divisible by 2
But
and
if
R2 is
we,
divisible by 2, then when you multiply, they'll be divisible by 4. But if they're like separate, it'll be 0.
but if we prove
yes.
that floor of log to the base P of AB is equal to floor of log P of A plus floor of log P of B, then we can prove this too.
What do you? The issue with that is, what do you think this is? This is 1, right?
Yes.
But floor of log 2.
Yes.
Is,
Yes.
these
This
are
becomes
very
ridiculous.
these are very different things.
Yes.
Great. So, okay, let's say A, B, C are naturals, and you have A plus B equal to C. What can you say about VP of A? So suppose case
Yeah,
1.
VP of A plus VP of B is VP of C.
No,
Okay.
no, that does not make sense.
Oh wait, it's not.
So take the first case. Suppose VP of A is not equal to VP of B. Then what can you say about VP of C?
It is greater than VP of 2A or 2B.
Is it?
But it just not it's a trivial thing.
Can you see that this is true?
Yes.
Give me a proof. Just a quick proof.
We can just assume that like one of them is greater, and like so for this equation to have a solution, it should okay.
Can I tell?
Yeah, sure.
Just consider B to be some P to the power K into some N1 and A to be P to the power of some D into N2. Then we can consider that K is smaller than D and add these things up. So we get that C is a multiple of P to the power of K. So it makes sense here.
Yeah.
And the latter thing will not be divisible by any power of K.
Yes. Great. And what if what can I say about
VP of C is equal to VP of A is equal to VP of B.
really?
But it depends on the P itself. Like if P is some 2, then it becomes +1.
That's not necessary, right?
Yes, yes.
Like VP of 2 plus 254 is 256. This has VP 1. This has VP what? What's V2 of this? 4 times 4 8. Right?
Can you consider modular here?
So so the thing is you can all you can say is this is greater than equal to. That's all you can say. Like here you can explicitly point out, like you can explicitly calculate what VP of C would be. Here this is all you can say. You cannot get a upper bound on VP of C. Because you see what happens is you have 2 plus, let's say, 2 power n minus 2. This is 2 power n, right? This has only one 2 in its prime factorization. This also has only one 2. This has n 2s. Make sense?
Yeah.
Great. So I'll just give a remark. Is this fine? So if A and B have equal VP, then we are done. If A and B don't have equal VP, then C will be the minimum of those, and then A and C or B and C will have the same VP. Hello.
Yes, got it.
Right. So here's what we have. We have VP of AB equal to VP of A. And the function f we want is kind of different. So first thing we want this property. Next we want, and then we also want can you see a way to get a f using using VP in some way? Because these properties are very similar.
Consider modular.
What do you mean by
absolute value? Absolute value. Considering absolute value. If we use absolute value here, we can like absolute value of VP of A.
so you're saying f of A equal to absolute value of VP of A?
Yes.
That does not satisfy this thing.
It doesn't.
So the thing is, you want to go from a additive function to a multiplicative function, right? And a good way to do that is to consider, let's say, something like f of A equal to p power VP of A. Does this work?
Yes, it does works. Works very times.
Okay, tell me a proof.
For the multiplicative thing, we can easily prove by that we have VP of AB is equal to VP of A plus VP of B. Then we will have f of A plus B is equal to P raised to the power VP of A into P raised to the power VP of B. So we are done proving the
Yeah,
multiplicative. Now for the uh, for the additive part, we have that P raised to the power VP of A plus B is like shorter than B is
it will
equal
be
to
bigger than. It
it
will be
is equal
bigger
to
than.
yes.
Yes, I think it's P raised to negative nu P of A.
Yeah, exactly. So this is the thing that works. So this clearly works. This also works. Someone give me a proof of this.
When it was like positive, it was greater. Then we have just to go about inverse.
Okay, so yeah, formally we have 1 by p whole power is less than equal to minimum of actually greater than equal to maximum of right. This just comes from raising everything to 1 by pth power. They take this inequality, do a that's not that what I wanted to do. Take this inequality, raise it to the pth power, take inverses. You get this. Or actually, you get this. Yeah. Great. So f of a equal to 1 by p power dp of a. Sure that was good. How does that help us? So what does this look like? So you have 0, and then at a distance 1 by p, you have, let's fix p equal to 2. At a distance 1 by p, or at, let's say, at distance 1, you have numbers like 1, 3, 5, 7. These are, then at distance half, you have 2, 6, 10, 14. Right? And then at distance 1 by 4, you have 4, 12, 20, and so on. So the more p's a has in its factorization, can someone explain this statement?
Yeah, it's because the distance keeps like decreasing when you get in like further in.
Yeah, great. So this is a very like weird picture to care about, but okay, bear with me for a second. So we have a distance from 0 to a, is defined by f of a. Suppose, like, what should be a good definition of a distance between 2 points a and b?
FB minus FA.
So we want it to be, let's say, 0 comma b minus a. So f of b minus a is the same as f of a minus b. Make sense?
Yeah.
Great. So we have a very different distance function on q, right?
Would it be a minus b or b by a?
We want it to be preserved in the translation state.
Okay.
Because it's just a distance, right? It can be like either way.
No, he was talking about b by a, f of b by a. That does not work. We need b minus a or a minus a. Well, that's what he was talking about. So, but how would you think of it? So this is how you should think of this distance function. Two numbers a b are close. You can only have a high power of p divides a minus b. Make sense? I just translated this statement.
Okay. Yes.
Great. So, all right. Let's see. I'll end with this last. So, usual distance function, and suppose we want to show. So we define S1 to be 1, S2 to be 1 plus half, S3 to be 1 plus half plus 1/4, right? And we want to show that Sn goes to 2. And the way we'll show that is we'll show that distance between 2 and Sn, which is just mod of 2 minus Sn, goes to 0. And this is how it why it pictorially goes to 0. You have 0, 1, 2, right? This is S1. S2 is 1 plus half. So somewhere here is S2, here is S3, S4, and so on. Make sense?
Yeah, it's just limiting it to 2.
Yeah. Can you give me like a formula for this 2 minus Sn? Like in terms of n, a formula in terms of n. Or let me actually do it as 0, S1, S2. So what's 2 minus S0? 2 minus S0 is 1. 2 minus S1 is
1/2.
2 minus S2 is 1/4. 2 minus Sn
For a
would be
G.
1 by 2 to the n. Right? That is what happens, right? This distance was 1, then it halved again, then it halved.
Like the general term of the GP.
Yeah. So the distance between 2 and Sn is 1 by 2n, or 1 by 2 to the n. And this definitely goes to 0 as n goes to infinity. So we say that this infinite sum is equal to 2. Is this clear?
Yes.
Yeah.
All right. Great. So P-adic norm. That is to say, 1 by 2 whole power v2 of a. This is our distance function now. And let's try to make sense of this. So S0 is 1, S1 is 1 plus 2, S2 is 1 plus 2 plus 2 squared. So we want to find the distance between -1 and Sn. Same as before. Does the problem make sense?
Yeah.
All right. Give me a formula for the distance between -1 and Sn. So let's try a few things. So this would be what? This would be f of Sn minus 1, right? So f of Sn plus 1. Done. Give me a formula. Take your time. Give me a
That
formula.
was f of a comma b is f of b minus a.
Oh, same thing happens. Right? Distance between a and b is same as distance between b and a. The highest power of 2 dividing a number is same as the highest power of 2 dividing the negative of that number. So sign is not an issue. Okay, let's see. What's f of S0 plus 1?
f2.
Which is right, and this is just
1 by 2.
great. What's f of S1 plus 1?
F of 4. One by 4.
Now, what do you think?
1 by 2 to the power of n.
Right? And this definitely goes to 0. So this is your picture. You have minus 1 here. You have 1 at distance half. You get 3 at distance 1/4. You get 7 at distance 1/8 and so on. Right? So is the proof fine? Can you see that this statement makes some sense? At least in the 2 I did not. All right. That's the
Yeah.
last thing. Any doubts? Anything? I'll give you a few references if you want to read about P-adic numbers. But before that,
Like whatever we have done till now, like this is intuitively it seems very wrong, but then after all of this hard work, it seems fine.
you get some result out of it, so it seems right. Sure. All right, I'll give you a few references and
Is there any particular reason why this is called like P-adic? Like, what is the reason for this?
oh, okay. I have no idea about that. No idea. Why would they call it P-adic? No idea. So we should check out this thing called Monsky's theorem. This is not a reference, it's just a cool result to know. And maybe you'll find this on Wikipedia. So this talks about we should check it out. I think there's a book called Introduction to Modern Number Theory. either Ivan Niven or Rosen and some other guy. This has one chapter on a few chapters on P-adics. You want some another would be Fernando Govia's book. So, but the thing is, this might require you to know some terms. It might require you to like. If you read this book, you maybe need to know what a field is, what you know, and some familiarity with this kind of arguments, distance going to zero arguments, some whatever the topology means and all that. But I think you can pick it up. Like if you want to learn periodic in high school stage, it's probably best to. I think one of the best ways is to just pick up this book and like few of the words might be scary. What's a topology? What does real analysis mean and all that? But you can pick that up on the side and just read, keep doing whatever number theory you are doing. Great.
There is an S after the N, like it's Monskis.
Yeah, Mons. But unless I'm spelling it wrong, it should be Mons. Great. I'll stop. Great. Thank you for attending. Any last thoughts?
So like what was the origination? Like what was the first thing that came to the mind of those people? Where would they?
So, in some sense, there's this guy called Kurt Hensel, German guy, who sort of started this P-adic thing. So one notion was to do the generalized formal series, mod P or something. The other more natural thing was to, trying to solve equations modulo P, P square. We tried to solve x square minus 2 mod 7, 7 square and all that. That's how it started. And then people realized that there's a lot more to it than just solving equations mod P. You can actually do analysis on it, not just number theory. So you can do calculus and all that on P-adic numbers. So it's a very nice thing to do. And the calculus on the reals gives you strong results. So on P-adics also, like you would expect it to give you good results. All right, I am thinking let's end the meet. Thank you for attending.
Thank you.
Thank you.
Can you stop the recording?